Alright, welcome to our first BC lesson of 2020. So this actually goes back to chapter 4, and it ties into the trapezoidal rule and left and right Riemann sums. And so basically what they're doing is through any 3 points we can determine the equation of a parabola. We could use a regression equation. So we're going to use the endpoints and the midpoint here, and that'll give us this parabola, and you can see that that parabola approximates the area under the curve here. And if we broke it up into a parabola on this side and a parabola on that side, then the area approximation would be even closer, and we can do the same thing here. So that's what they're showing us down here. This is a graphic where it moves and shows more and more parabolas. So here there's one, and then here's another one, and then here's a third one. So they're using 3 different parabolas, and then we would find the area under those. So that doesn't really apply, like you don't have to apply that to anything. Simpson's rule is just going to be this here. So it's going to be b minus a over 3n, always, for Simpson's rule. And then you start off with the original, and then you have 4, 2, 4, and it follows that pattern, 4, 2, 4. So the next thing here would be another 2, and then a 4, and it alternates until you get to the end. This only works for an even number of subintervals. Okay. All right, so if we try that out here. So b minus a is going to be 2 minus 0 over 3 times the number of subintervals, which they told us to use 4. So that's going to be 4. And then we're going to multiply that by the function at the first value, which is going to be f of 0. Plus, and then we're going to have 4 times f of, and we're going from 0 to 2 with 4 subintervals. So if we want to find the amount, the increment that we're going by, we're going to take 2 minus 0 over 4, and that's going to be 1/2. So this next value is going to be 1/2, and then 2 times f of 1, and then 4 times f of 3/2. And then now we're back to the end, and so that's going to be f of 2. All right. So cleaning up over here a little bit, that's going to be 2 over 12. So that's going to be 1/6. On a free response question, we're not going to want to do too much of that math because we might make a mistake. But I mean, that's pretty clear. Anyway, so f of 0, you're not actually, I guess it would help if you could see that, right? Okay. So anytime we're doing these video notes, if you can pause them and try to do part of it yourself, that would be better than just sitting there copying what I'm writing. So I was just filling in the formula, though, according to what we have up here. So, back to now that you can see it, f of 0, we're not integrating this, we're using this to approximate this integral. So we're not actually going to integrate that, except when we compare it to the exact value there. But so if you plug a 0 in there, that's going to be 0. Okay, now here, it's going to be 4 times 5 times, if we plug a 1/2 in there, it's going to be 1 over 2 to the 4th power. 1 over 2 to the 4th power. But if we think about that, 2 to the 4th power is 2 squared times 2 squared. So I'm just going to write that as 4 times 4 because that's going to cancel out. Okay? So doing a little simplification here, that's going to be 5 over 4. All right? And if we move over here to 1 and we plug a 1 in there, that's going to be 5. So 5 times 2 is 10. So that's going to be 10. Now here on this next one we have 4 and then 5 times, we have 3 to the 4th power, that's going to be 81, and we have 2 to the 4th power, which I'm going to write as 4 times 4 again, 2 to the 4th power. Okay, so these 4's are going to cancel out. So that's going to be 405 over 4, 405 over 4. Oh, I left the 10 out there. That's a little awkward. I could have added this guy. So, and then we plug in a 2. 2 to the 4th is 16 times 5 is 80. So that's going to be 80. So I'm going to go ahead and put those two together. Pretend like I was waiting to do that anyway. So that's 90. Okay. So this is 410 over 4. So 410 divided by 2 is 205 over 2. And I'm going to get a common denominator here, so I'm going to multiply that by 2 over 2. So that's going to be 180 over 2. And that's going to be 385 over 12, which is the answer. All right. Now, if we find the exact value on that, so if we integrate that, add 1 to the exponent, divide by the new exponent, we would have that, and this is going to be from 2 to 0, so that's going to be 32 minus 0, which is 32. So if we compare that, I'm just going to check on my calculator real quick, and 385 divided by 12 is 32.083. So that is pretty darn close, pretty good approximation. Remember, in AP Calculus, we have to round off to the thousandths place accurately. So, all right, so here we have a table of values instead of a function. We've got to make a little change to the table here because on the other side it said that to use Simpson's rule you have to have equal widths. And so this needs to be 1, 2, 3, 4, 5. The gaps between there need to be constant. So we would not be able to use Simpson's rule on this table the way it was. So you don't need to highlight that in orange, that's for me. That means I need to change that. Oh, and we also need to change this here then. So it's going to be 1 to 5 instead. All right. So using Simpson's rule, that was b minus a. So that's going to be 5 minus 1 over 3n. And that's going to be 1, 2, 3, 4. N is going to be 4. It's going to be 4 subintervals. And then we multiply it by the value of the first one, so that's going to be 10 plus 4 times the value of the next one. Now in the other problem we had to calculate what we were going by in between, but here we have those values. So that's just going to be 4 times 20, and then it goes down to 2, and that should be 30. And then it goes to 20. And then it goes back up to 4. It alternates 4, 2, 4. And then that's going to be 40. And then the last term is just the value. So that's going to be like that. So that's going to be 4 over 12, which is 1/3. And here we can combine some things. I don't want to do too much at the same time, so that's going to be 40 plus 120 plus 40 plus 160. Make sure I have that right. That, and those two. Okay. So that's 200, 320, 360 divided by 3. So 360 divided by 3. And that's going to be 120. Okay, now both the examples we did had 4 subintervals, So that's why the pattern went like this. If it had 6, then we would have had another, we would have had plus 2 times whatever, and then another 4. So every even number after that, you'll have another 2 and another 4 in there. Okay? Trapezoidal, should have went over this in the notes already from reviewing for last year, but that's going to be 1/2. Because these are going to be all at equal increments in this situation, we can also factor out the heights, which is going to be 1. But normally, so if the heights were not equal, we would have 10 plus 30 times that first height. But because they are equal, we can realize that we're going to get those same bases 3 times. Maybe I should have done it the other way, just in case. And then we could factor out the height, which in this case is 1, the gap between those. So if those gaps were not equal, then we would need to do that a little bit differently. So we would have had 1/2, and then we would have had 10 plus 30 times 1 plus 30 plus 20, and that would be times those different heights. I guess I could have put that up there. But because those heights were all equal, we could factor them out, and because they were 1, it didn't really matter anyway. So, coming back here. So I just put that there in case the heights aren't equal. So 10 and 30 is 40 plus 2 times 90. Okay, so that is 180 plus 40 is 220. So half of 220 is 110. Okay, so if you compare those, I'm guessing that is probably a bit closer to the actual value. All right, and then one more. I'm going to try that again one time. And again, 4 subintervals, so that's not very creative on my part, but oh well. So that's going to be, so here's be a good place to pause the video and try to do this example yourself. Hopefully you don't have to look up there. You've seen it twice now, so try to remember. And pause this and then come back and play it one step at a time, and then pause it and check each of your steps. All right? So here we go. Welcome back from pausing the video and trying the problem yourself. B minus A over 3 times the number of subintervals. So that's going to be 4. All right? So a little bit trickier here because so we've got to find it 3 minus 1 over 4. That's going to be 2 over 4, which is going to be 1/2. So our values here, we're going to start by plugging in 1. So if we plug 1 in there, we get 1 plus, always start with a 4 for Simpson's rule, so 4 there. And then we're going to plug in, we're going to add 1/2 to 1, so that's going to be 3/2. And that's what we're plugging in. So we plugged in 1, and now we're plugging in, so we're plugging in 1, and we're plugging in 3/2, and then we're plugging in 2, and then we're plugging in 5/2, and then we're plugging in 3. So those are our values going by halves to get our values. So then we alternate 4 to 2, and now we're going to plug in 2, and then we go to 4 again. We're going to plug in 5/2, and then back down just to the function, and that's going to be at 3, so that's going to be 3 squared. So I could do this instead. Use a bracket. All right. We could use parentheses there, just bracket helps set up the layers a little bit better. So that's going to be 2, that's going to be 1/6 again. And then in here, That's going to be 9 plus 1 is 10. And here, squared, that's going to be 9 over 4, so that's going to be 9. And here, 4, that's 8. And square that, that's 25. The 4's cancel out, and I already did the 9. So, okay, that's going to be 17, 27, 52. So 1/6 of 52. That's going to be 26 over 3. All right, so if we do the exact value here, if we integrate that, add 1 to the exponent, divide by the new exponent from 1 to 3. So that's going to be 27 over 3, which is 9 minus 1/3. So that's going to be 8 2/3 is the exact value. And if we take this in, that's going to be 8 2/3 also. So that's because that is a parabola. So if we used a parabola to approximate the area under the curve of a parabola, it's going to be equal. All right, so hey, congratulations. Just finished our first Calculus BC topic. So what are we, class? That's right, smart and good looking. All right, see you later.